Hello, everybody. Here is Zaghloul, a senior software developer. In this series, we are going to talk about how to build a startup Laravel project when you don't know the next scenario. And the first video at this series, today video, is about infrastructure choice. Of course, you have too many choice: monolithic app or distributed system. When I say distributed system, I mean by it both. Approach like service oriented or microservice based. I know there are a little bit difference between these two approach, but this is not our today discussion. Okay, let's compare the pros and cons about monolithic and distributed system. Starting with the pros, you have for monolithic, easy to start, just one centralized code base, easy to deploy. You will deploy once, and all the parts will be deployed. On the other hand, the distributed system is good for scoping. Means, let's say you have a newcomer developer and you need them to be onboarded on ramp up on the relevant service. So if you split your code base onto modules, you have, for example, an e-commerce application. You have a persona module that carry user and admin data, and you have an e-commerce module for orders and something like this. So if the developer are going to work on a task related to the order, of course, he will work on the e-commerce module, not the persona one. So he knows the scope that he will work. He knows the strict API design, separation. Okay. Services are deployed in separation. So if one up and the other down, it will not be affected. Not all the service will be down like the monolithic one. Polyglot services with multiple framework and language. Let's say you have a service on your app needed for AI and machine learning, so you will type it in Python. The other service for web, you will type it using PHP or Node.js, something like this. So the monolithic and the distributed system. Monolithic have a large scary code base when we talk about the concerns. They are centralized. When you need to roll back an effect or a bug, you will roll back all the parts of the code base. Spaghetti code and tight coupling may be founded. You are locked to one technology language. If you need to scale a part of your app, you will scale all the app because they are centralized at one code base. On the other hand, the distributed system have complex structure. Clean API design is hard because you need to know the scope of every service. The communication may be hard because one service is up and the other is down. Maybe remote procedure calls failed, founded. So handling the stateful things like database transaction and sessions is not an easy. Query multiple databases is not an easy way. Okay, maybe a little bit slower because of network calls. Versioning compatibility. Let's say we have version A from e-commerce service and version 1 from e-commerce service and version 2 from the authentication. You may face a different compatibility issue. System integration for tests is complex. So let's talk about how the service talks to each other. Of course, using one of these ways, the remove procedure call or message broker. Remove procedure call, if we talk about monolithic, it will be a functional call. You just call the function or the method you need from the class or the module. And for the system distributed system, you will have found a network calls like HTTP calls. On the other hand, something called message broker founded to solve the problem of remove procedure calls, but it has its own complexity and its own pros and cons. So for remove procedure calls, it is easy to configure, no configuration, easy to be handled with a small tech team, doesn't need expertise for it. Message broker is good for async relay and work distribution, means you can scale out, scale horizontally easily. You have a service and you have another replica. So if one is down, the other is still available. Okay, let's talk about the cons of remote procedure call and message broker. For remote procedure call, you may have a temporal coupling or timeout might be found that duplicate delivery means if we have a service for wallet and the other for transaction, so the money is added to the wallet, but it doesn't affect the transaction or vice versa. So this is not good. On the other hand, message broker have its own complexity issue. You will have another service as a message broker. So you have a limitation for how large the loops will be sent. You need an expert one to set up your dead queues. It is one more service to monitor. You doesn't know how to guarantee at most once or at least once or exactly once delivery status. So the suitable solution I found here from the discussed is going for modular monolithic approach. Modular monolithic approach can be delivered by two main ways. One for it is modular monolithic architect like HMVC or the domain-driven design. So if you need to implement it easily, you can use one of the packages like NVDirt for modular monolithic one, and you can find this package. I think the developer for it, full stack Jack, thanks to this man. So the difference between domain-driven design and modular monolithic. Modular monolithic give you a complete separation for any module. You can build a module like a package, reuse it at any another project. It's more complicated than domain-driven design because domain-driven design will save the shared things like routes or modules. But two approaches good to start your project. This package have some comments like module enable, module disable. You have your own composer JSON for module states. So by one comment, you can say module disable persona. So he will drop the persona module and you can take it for a microservice. And on the other hand, here is the structure of domain-driven design. This package have some comments like domain make. It will make a domains folder for you, and any domain will be like this, have the following structure. So here we go. That's the first video about infrastructure. Keep contact and see you on the next video. Have a nice day.